Hello dear students, welcome to LFI Educates. So here we are with the second video of determinants, and in this video we shall learn about how to find the area of a triangle using determinant. So in your grade 10 you have, or in your grade 9 also, you have learned about how to find the area of a triangle. So using if three coordinates are given, so you have used this formula, that is half of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2, using this formula. But how this formula look like? Can I change it to a determinant form? Let us see. Here if I write the determinant x1, x2, x3, y1, y2, y3, 1, 1, 1. Are they same? Just check it out. If it is x1, along with a half. If it is x1, so we shall have the remaining determinant, that will be y2 into, so this will be y3. y2 into y1 will be y2 and minus y3. So we have x1 into y2 minus y3. Plus, we have x2 here. So exclude this row and this column. So we shall have y1 minus y3, but we have taken y3 minus y1, and since there was a negative sign earlier, so we have changed it to positive sign. Fine. And next we have x3. So excluding these two row and column, we have y1, y2, and here 1, 1. So it will be y1 minus y2. Fine. So we are getting the same thing, isn't it? You can try it yourself once and you must get the same thing. So if we are able to find the value of this determinant, then we can say, or we can find the value of the area of a given triangle whose certain coordinates are given, or three coordinates are given. Okay. Now one more thing about the area of a triangle while finding is that whatever may be the value of this determinant, rather it may be negative, sometimes it may be positive, so always we need to consider only the absolute value, or we can say the modulus value. So if it is negative 5, we shall take 5. Even if it is 5, we shall take 5. Okay, we shall take always the absolute value. And if the area is given, if in the question the value of the area is already given, then we need to consider the negative as well as the positive values for our calculation. And the most important part while discussing the area of a triangle is that if 3 points are given, and they are collinear, we know that a triangle is formed by 3 points, isn't it? So if all the 3 points lies on the same line, then what? Then they are called collinear. Okay? And in that case, the determinant will be equal to 0. Now let us see exercise 4.3. The first question that we have considered here, that is 1 Roman 2. So we need to find the area of this triangle where three coordinates are given. So we have the formula of the triangle, that is to find the area of the triangle, that is half of determinant of x1, x2, x3, y1, y2, y3, 1, 1, 1. So here let us consider x1 is equal to 2, y1 is equal to 7, x2 is equal to 1, y2 is equal to 1, and x3 is equal to 10, y3 is equal to 10. Now to find the area of the triangle, how to do it? Determinant of x1. What is our x1? It will be 2, x2, so half is there, 2, 1, 10, 7, 1, so it will be 8. 7, 1, 8 and 1, 1, 1. Fine. So this is the determinant and we need to find the value of this. So this will give us half into 2 into what? Exclude this row and this column. So we shall be remaining with 1, 1, 8, 1 plus, minus here. So 7 into, exclude this row and this column, so we shall be remaining with 1, 1, 10 and 1 plus 1 into, exclude this and this, so we shall be remaining with this part, there will be 1, 1, 10, then 8. Okay, so here write the half. So this will be 2 into 1 and 8 1 8 minus 7 into 1 minus 10, just cross multiply both, plus 1 into 8 8, 10 into 1 10 with a negative sign. Okay, now what to do? Just calculate this. This will be 7 minus 14, here it will be minus 9 plus 63, 9 7 63, and here it will be minus 10 minus 2. Fine. So this will give us half of 63, 61, 7, 47. So this will be equal to 47 by 2 square units. Fine. So very easy to find the area of a triangle using determinant. Now let us see another question. So in question number 4, they have said find the equation of line joining 1 2 and 3 6 using determinants. So in question number 4, we shall use the collinearity of 3 points. So here you can see that one of the coordinate is given 1 2 and another coordinate is given 3 6. Fine. Now find the equation of a line. That means whatever you draw here, it will be a line. So let us take another point here. Okay, so let us take a point here which is xy. So let us consider that as P. Now since it is a straight line, so all the 3 points, they will be collinear to each other, isn't it? And if they are collinear, then their determinant will be what? It will be 0. Okay, so since the determinant is 0, now let us write here the points are 1 2 and 3 6. Let PXY be a point on the line. So since this point is also on the line, so they will be collinear, isn't it? So therefore the determinant, or we can write determinant, that is half of x1 x2 x3 y1 y2 y3 1 1. So what is this? By this, using this determinant, we can find the area of the triangle. So this will be equal to what? 0. Now from here I can write in place of x1, what is our x1? Let us take this point 1, x2. x2 is because since this point we have taken in the middle of these two lines, of these 2 points, so this, let's consider this as the point x2, and x3, here we have 3. Okay, for y1 take this 2, for y2 take y, and for y3 take 6, and the last element we have is 1 1 1, and that must be equal to 0 by collinearity of points. Okay, now since this is scalar, I can take the 2 that side, so this will be done. Now find the determinant of this. So at first we have 1 into, since there are no zeros, so we can find the determinant with respect to any of the rows or columns. So 1 into y1 6 1, excluding this row and this column, this part, minus 2 into what? Which determinant we need to take? Exclude this and this, so remaining thing x1 3 1 plus 1 into xy 3 6, and that is equal to 0. So from there we shall find a equation. Let us see what is the equation that is going to form. Now this will be equal to y into 1 will be y minus 6 minus 2 into, just remove the bracket, no need of that, 2 into x minus 3 plus x minus 6, sorry, plus 6x minus 3y, and that is equal to 0. So this will give us y minus 6 minus twice x plus 6 plus 6x minus thrice y is equal to 0. So we have a y here, we have a minus thrice y here, so we shall be remaining with minus 2y, and we have a minus 6 here, plus 6, we can cancel out both of them, and we have minus 2x plus 6x, so it will be plus 4x is equal to 0. So we shall have, we can cancel out the 2's as well, so this will be equal to minus y plus 2x is equal to 0. So our final answer will be y is equal to 2x. So this is the equation of a straight line, isn't it? So where slope is 0, where the intercept is 0, and that will be the end of your exercise 4.3. And in the next topic, or in the next video, we shall come up with minors and cofactors. So till then, practice all the problems that are in the book and also in the examples, and whatever PDFs that I am going to give, so please follow them and stay home and stay safe. Thank you.